and welcome to another episode of FooBar. In today's video, we are going to talk more about Kinesis Data Streams, how the shards work, what is on-demand mode, what is provision mode, when to use each of the modes, and then at the end we are going to create our first stream using AWS CDK. In the on-demand mode, we are going to send events and receive events and see how all this comes together. So let's get started. In a previous video, we introduced Amazon Kinesis Data Streams, what we can do with it, what it was, and so on and so forth. We say that Kinesis Data Streams takes data generated from different producers and ingests them into shards. Then different consumers will read the data from the shards and do something with it. We talk about producers and we talk about consumers, and we briefly talk about shards and the difference on how you can provision shards into the data stream. In this video, we are going to get more in depth. No matter which mode you select, on demand or provision, you are going to have shards in your stream. A shard is a uniquely sequence of data records in a stream and provides a fixed unit of capacity. Each shard can support 5 read transactions per second or 2 megabytes per second, and they can write up to 1,000 records per second, up to a maximum total write of 1 megabytes per second. Inside a shard, you're going to have records. Records are an immutable unit of data stored in a Kinesis data stream. Records are composed of a sequence number, a partition key, and a data blob. Kinesis data stream doesn't inspect, change, or interpret the data blob in any way. The partition key is a value that will define in which shard this record is going to be stored. You are going to set that partition key. Kinesis data stream uses a hash function to define in which shard each partition will be. In one shard, you can have multiple partitions. The sequence number is unique per partition, and Kinesis data stream will assign it to the record when writing it into a stream. This means that you don't need to assign a sequence key. Records are put in order into the shard, but the order is not guaranteed between the shards. So now that you understand a bit more on how shards work and what they are, you might realize how important shards are to determine the throughput of your stream. If you need more capacity in your stream, you might need more shards. So how you define the amount of shards that you have in the stream for the capacity that you have? There are 2 ways of provisioning shards into your stream: provision and on-demand. So let's see some examples of workloads using a provision stream and see how well they fit. The first example is a stable workload. Here we can see in pink the provision capacity that is around 55 shards. We have the actual usage in our stream, that is that green line that changed a little bit through the day. And then we have the average usage of our stream that is set to around 42 or 43 shards. You can see the difference between the pink and the purple line not to be massive, so we are not wasting capacity, we are not over provisioning. So this is a good match for a provision stream. You know more or less how much your workflow is going to consume, it's stable, and it just works for you. However, if we have a workload like this, a highly variable workload, in where we have a spike through the day because our customers come late at night, or maybe it's a monthly spike or some kind of spike that you know it will happen, and it's dramatic in difference of the stable capacity, then the provision mode might not work very well for you. Let's look at this example. Here we have this workload working on a provision stream. We are provisioning around 80 shards, and you can see that the normal traffic is less than 10 shards per hour. While during the spike, at the end of the day, it spikes up to 80 shards. And then if you check the average usage and the amount that we are provisioned, that difference is huge. So we are wasting a lot of capacity. We are really over provisioning our stream just for that particular spike. So in this case, an on-demand setup will work better. We will have the amount of shards that we need when there is not much traffic, and then the amount of shards going to increase accordingly to our needs. And let's look to the last example. When we have an unpredictable workload, we don't know how much data we are getting. In this case, we are provisioning around 80 shards. And during the day, it's mostly okay until in some point it snapped and it just spiked to 160. If you're in the unprovisioned mode, that red triangle that you see in screen is going to get throttled. All those records are getting throttled. They are not going to get stored in the stream because we don't have enough capacity provision. If you use on demand, then the demand will adjust, the capacity will adjust to your demand, and then you are not going to have that problem. Unpredictable workloads and highly variable workloads are great for on-demand capacity for the Kinesis data stream, while stable workloads are great for provision streams. So now let's go to the code and see how we can create a stream using AWS CDK on the provision mode. So here I have my CDK project. You can find this code in the link in the description box. You can find the branch because in this project we are going to do a lot of things with Kinesis Data Stream. We are going to evolve this code a little bit more. So this is the first iteration. Just look for the right branch and you will find it. So here we have the stream. It's very simple. We have a stream name and a stream mode. And then when we deploy, we do CDK deploy, we will see in our console the stream in Kinesis. So here we can see the status, we can see the capacity mode, we can see the retention period, we can see how we can consume and produce. We are going to check that later. We can see the monitoring. There is some activity going on there because I was doing some tests. We can see the configuration. We can here see the capacity mode and the write capacity, 200 megabytes per second or 200,000 records. We can get as maximum of write capacity and read capacity, a maximum of 400 megabytes per second. We can edit that. We can see the encryption, the data retention. We have here the data viewer that we are going to check in a second. So this is our stream. It's very simple. So what if we want to send records to our stream? We can use the producers. We can use the Amazon Kinesis agent. That is a standalone application that we can install and run in our computers. We can use the AWS CDK, basically from our applications. We can use the Amazon Kinesis producer library from our applications as well to send events. We can use the AWS CLI, as I'm going to show you right now. So if we go to the code and we type something like this, we are going to use the AWS CLI, the command line, to put a record into my data stream with the name test, with the data test data and the partition key 1. Let's change the partition key to 2 and see what happens. So here we have the shard is number 3, then the sequence number that it just generated for us is this, and the encryption type is that. So let's go to the console, to the data viewer, and here you can see all the shards that we have. This is an on-demand mode, and on-demand by default provision 4 shards until it needs to start scaling. So we said that in the shard 3 is where we will find that record. So let's search for it, and here it is. It looks weird, I know, and you might be wondering what is happening. I can tell you, this is because it's base 64 encoded. So AWS CLI expects that you pass the data base 64 encoded. And then when the data viewer is decoding the data and showing it to us. So this is the problem. So in order to get it right, what we need to do is to pass something like this. So this is something like this. We need to pass the put record, same message, same data stream, and then here some gibberish. And then we put it in the same partition key so you can see it. So it's in the same shard because the same partitions goes to the same shard. It's a hash function. We have a different sequence number. And then if we get the records, here we can see that it says test data. Why is that? Because this message is base 64 encoded of test data. And then when this record data is showing it to us, is unencoding it. So we can see that here. You might be wondering how we can consume the data. Again, there is many ways. We can consume the data from other applications. We can have Kinesis Data Analytics. We can send it to a Firehose. And we are going to see different ways of consuming the data in a programmatic way in this series of videos, so stay tuned. So that's the video for me today. I hope you enjoy it. Give me a thumbs up and subscribe because more videos on Kinesis are coming. Around here you can find the full playlist on Kinesis and data streaming, and here you can find the latest video on Kinesis, so if you don't know what I'm talking about, go and check it out. And I see you in another episode of FooBar. Ciao ciao!